What is quantum tunneling's secret in flash memory? Imagine electrons sneaking through walls like ghosts in a spooky house. That's kind of what quantum tunneling does at a tiny scale. It's a strange quantum phenomenon where particles like electrons can pass through energy barriers they normally shouldn't be able to cross. This happens because particles act like waves, and their wave functions spread out beyond barriers, giving a small chance they appear on the other side. In flash memory, this weird effect is the secret sauce that makes modern storage possible. Flash memory stores data by trapping electrons in tiny floating gates, which are insulated by super thin layers of oxide. These electrons representing bits of information, either a 1 or a 0, by their presence or absence. The magic happens when a voltage is applied. Instead of physically smashing through the barrier, electrons can tunnel through the thin oxide layer, even though they don't have enough classical energy to jump over it. This tunneling allows electrons to move onto or off the floating gate, changing the data stored there. The oxide layer is engineered to be just a few nanometers thick, about 7 to 8 nanometers, so that when a voltage is applied, the energy barrier becomes effectively thinner. This makes tunneling happen exponentially faster, allowing quick writing and erasing of data. The thickness is carefully balanced. If it's too thin, electrons leak away too fast, risking data loss. If it's too thick, tunneling slows down, making data writing slow. This precise control ensures data can be stored for decades without losing integrity. Because of this quantum tunneling, flash memory is non-volatile. That means it keeps data even when the power is off. When no voltage is applied, the barrier is thick enough to keep electrons trapped for many years. But when you want to change data, applying voltage causes electrons to tunnel in or out rapidly. From a strange science perspective, it's wild that a quantum effect usually seen at the atomic level is used in everyday gadgets like USB drives and smartphones. The fact that electrons can mysteriously pass through walls inside a chip to store your photos and files is a quirky example of quantum weirdness in action. So, the secret of quantum tunneling in flash memory is that it lets electrons bypass classical energy barriers by exploiting their wave-like nature. This tiny quantum trick makes reliable data storage and quick erasing possible, powering much of the digital world we relying on daily.